everyone, my name is Abby Lewis. I'm a PhD student at Virginia Tech, where I'm studying freshwater biogeochemistry and ecological forecasting. And I'm also one of the co-leads of the FE theory working group. So I'm going to be telling you a little bit about that group today. I think the fundamental argument that the theory group makes is that ecological forecasting is not just useful for ecological management, although it's obviously making really important contributions in that area. We think that forecasting might also be useful as a tool to advance basic ecological theory, at least theoretically. Most of the ways in which ecological forecasting can contribute to basic ecological theory are only recently starting to be explored. The main question that we've been considering is when, where, why, and how is nature predictable? And as we started talking about this question, we realized that this is a question that's only possible to answer if we have a shared vocabulary. So we spent a long time coming up with definitions for commonly used forecasting words, and those definitions are now being used as part of a paper that the education working group is putting together. The next task that we've been focusing on is developing predictions for the FE challenge. So this could be anything along the lines of which target themes will be easiest to forecast, which will be the hardest, ranging to also like what sources of uncertainty will be most influential or lead to the most error in each target area. And we spent a lot of time thinking about predictions for these sorts of questions. But then from those predictions, we want to generalize up to think about forecasts in general. So under what circumstances do we think that forecasts will perform best? Under what circumstances do we think it will be really difficult to create an effective forecast? And all of this is leading back to that original question of when, where, why, and how is nature predictable? So this is just a little taste of some of the hypotheses that we've created. In this figure, the x-axis is the forecast horizon, or the amount of time into the future that you're predicting, while the y-axis is the process scale of what you are forecasting. So something like tree diameter probably changes over a longer period of time, so you would say that has a longer process scale than something like chlorophyll that changes really rapidly. And our general prediction is that over longer forecast horizons, so the further out into the future that you try to forecast, your forecast performance is going to decrease. But at the same time, you might expect that a forecast for something like tree diameter is probably going to be pretty accurate for a significant period of time into the future. 2 weeks in the future, I'm pretty confident that my forecast of tree diameter is going to be pretty spot on, because I don't think tree diameter is going to change at all over the next 2 weeks. Whereas something like chlorophyll might change really substantially in the next 2 weeks. So you would expect that forecast performance might get worse faster for a process like that. So if you combine those two different aspects of predictability, you end up with something like this third figure that shows that forecast performance decreases in general the further out into the future you try to predict, but that decrease will occur faster for variables that have a very quick process scale. If you find that interesting, or if you find that unsatisfying and want to think more about the theory behind ecological forecasting, we would love for you to get involved. So one of the current projects we're working on is this paper entitled "The Power of Near-Term Forecasts to Address Fundamental Questions in Ecology." And we're preparing this for a special issue at Methods in Ecology and Evolution. Working on that paper will probably take up the majority of our meeting time for the rest of the year. So if you're interested in getting involved with that effort, I highly recommend you join our meeting on June 21st at 4 p.m. to see how you might be able to get involved. If you want more information and the Zoom link for that, you can join the theory group Slack channel. Meetings happen about once per month, and all of the participants are expected to contribute a couple of hours of work on the manuscript between meetings most months, but the overall time commitment is pretty light. So that's all I have. I'm really excited to talk to you all and hope that some of you are interested in getting involved. Thanks.